Okay, so hello and welcome back. Now in this video we will talk about essentially the multiplication table for 6 and some other multiplication tables. So the multiplication table of 6, basically when you say essentially if you have essentially 6 groups of 1, for example, so that's six groups of 1. So so then you have essentially 6 groups of 1. If you want to know essentially the total number of objects, that's essentially 1 plus 1 plus 1 plus 1 plus 1 plus 1 6 times, which is equal to 6. And 6 groups of 1 would be 6 times 1, which is the same thing, essentially 6, right? If you had essentially 6 groups of 2, meaning essentially 2, so that's essentially 1, 2, 3, 4, 5, and 6 groups of 2. The total number of objects, so that's essentially 6 groups of 2, and the total number of objects here would be essentially a 2 plus 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 a 2 6 times, which is equal to 12, right? And of course then 6 groups of 2 would be 6 times 2, which is equal to 12, right? And then by the same logic, that's essentially the meaning of these expressions, like 6 times 1, 6 times 2. And so then by the same logic, then we can essentially build the whole calculation table for 6, meaning that essentially we have basically 6 times 1, which is equal to 6. We have 6 times 2, which is equal to 12. We have 6 times 3, which is equal to 18. We have 6 times 4, which is equal to 24. We have 6 times 5, which is equal to 30. We have 6 times 6, which is equal to 36. We have 6 times 7, which is equal to 42. We have 6 times 8, which is equal to 48. We have 6 times 9, which is equal to 54, right? If I'm not mistaken, which is equal to 54, because essentially the difference has to be essentially always a 6. So 48 plus a 6 would be a 54. And then 6 times 10 is equal to 60. And then 54 plus a 6 is equal to 60. Right? So that's the multiplication table for 6. Right? Now let's talk also in this video about the multiplication table for 7. About the multiplication table for 7. And I have to turn this off. Now about the multiplication table for 7, it's again something simple like before. We have basically, suppose that we had essentially 7 groups of 1, for example. So that's 1, 2, 3, 4, 5, 6, and 7, right? That's basically 7 groups of 1, which means that essentially the total number of objects would be essentially 1 plus 1 plus 1 plus 1 plus 1 plus 1. So that's 3 and 6 plus a 1 is equal to 7. That's essentially 7 times 1. So 7 times 1 is equal to 7. Suppose that we had 7 groups of 2, for example. So that's 1 group, 2nd, 3rd, 4th, 5th, 6th, and 7th, right? So if I had 7 groups, so now I have essentially 7 groups of 2, right? So that, which means that essentially the total number of objects would be a 2 plus 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 a 2, which is equal to 14, right? And that's 7 groups of 2 would be 7 times 2, which is equal to 14, right? So again, the meaning of these expressions like 7 times 1, 7 times 2 is just simply these basically 7 groups of 1, 7 groups of 2, and so on and so forth, right? And so in the exact same way, we can build the whole multiplication table for 7, and that is essentially a 7 times 1 is equal to 7, 7 times 2 is equal to 14, 7 times 3 is equal to 21, 7 times 4 is equal to 28, and you see again that the difference between any two consecutive sums is a 7, meaning 7 plus 7 is 14, 14 plus 7 is 21, 21 plus 7 is 28, 7 times 5 is equal to 35, 7 times 6 is equal to 42, 7 times 7 is equal to 49, 7 times 8 is equal to 56, 7 times 9 is equal to 63, and 7 times 10 is equal to 70, right? Now, there is something also like the relationship that we found basically between different multiplication tables. There is there is another interesting relationship that we can find here, and that is the fact that basically if you use the multiplication table, if you want to create the multiplication table for 7, you can use the multiplication tables of 3 and 4, and you can see that 3 plus 4 is equal to 7, and this is the multiplication table for 3, this is the multiplication table for 4, and this is the multiplication table for 7. These are the sums. This is essentially one set of sums for the table of 3. This is another set of sums for the table of 4. And then if you essentially simply add these numbers together, you will get the sum for the multiplication of 7 basically. So 3 plus 4 is equal to 7, 6 plus 8 is equal to 14, 9 plus 12 is equal to 21, 12 and 16 are 28, and so on and so forth. So now let's see essentially why that's actually true. So if I write down the multiplication tables, if I write down the multiplication tables for 3 and 4, we will have essentially the following. So 3 times 1 is equal to 3, right? 3 times 2 is equal to 6. 3 times 3 is equal to 9, right? That's a and so on and so forth. That's the multiplication table of 3. Now 4 times 1 is equal to 4. 4 times 2 is equal to 8. 4 times 3 is equal to 12, and so on and so forth, right? Now the multiplication of 7 is 7 times 1 is equal to 7. 7 times 2 is equal to 14. 7 times 3 is equal to 21, and so on and so forth. And you can see that 3 plus 4 is equal to 7. Over here you can see that 3 plus 4 is equal to 7. 6 plus 8 is equal to 14. 9 plus 12 is equal to 21. And, well, the same thing keeps happening throughout all of these tables. Now the reason why that's true is that basically when you say 3 times 1, that means essentially 3 groups of 1. When you say 4 times 1, that's essentially 4 groups of 1, right? And when you say 7 times 1, you have essentially 7 groups of 1, right? So of course it makes sense that 7 groups 3 groups of 1, which is just a 3, plus 4 groups of 1, which is a 4, is equal to 7 groups of 1, which is a 7, right? So 3 plus 4 is equal to 7, right? When you say 3 times 2, that means essentially 3 groups of 2. So I have one group of 2, another group of 2, and another group of 2. When I say 4 times 2, I have 4 groups of 2. So 1, 2, 3, and 4, right? And when I say 7 times 2, I have 7 groups of 2. So I have 1, 2, 3, 4, 5, 6, and 7, right? So of course, 3 groups of 2 is 6, 4 groups of 2 is 8, and 7 groups of 2 is 14. And of course, 6 plus 8 is equal to 14. And so that's basically how this works. Meaning that, for example, you can use the multiplication table of 2 and for example 3 to make the multiplication table of 5, because essentially 2 plus 3 is equal to 5, right? Meaning, for example, 2 times 1 is equal to 2, and 3 times 1 is equal to 3, and 5 times 1 is equal to 5. So 2 plus 3 is equal to 5. Or for example, 2 times 2 is equal to 4, 3 times 2 is equal to 6, and then 5 times 2 is equal to 10, which means that 4 plus 6 is equal to 10. So this relationship exists among all the tables, basically, as long as essentially the sum of these two numbers is equal to this number that you want to create over here, right? So that's essentially the multiplication table for 7. And then we have essentially the multiplication table for 8. Now let me see what we have actually created so far. Now the multiplication table for 8. The multiplication table for 8 is again simple. For example, you would say 8 times 1, 8 times 2, and so on and so forth. And you already know essentially what is the meaning of 8 times 1, meaning 8 groups of 1, 8 groups of 2, 8 groups of 3. And so we have 8 times 1 is equal to 8, and 8 times 2 is equal to 16, and 8 times 3 is equal to 24, and 8 times 4 is equal to 32, and 8 times 5 is equal to 40, and 8 times 6 is equal to 48, and 8 times 7 is equal to 56. The difference always has to be an 8. So 48 plus 8 is equal to 56, and 40 plus 8 is equal to 48. 8 times 8 is equal to 64, and 8 times 9 is equal to 72. 64 plus 8 is equal to 72, and 8 times 10 is equal to 80, right? Now the only thing that remains is the multiplication table for 9. So let's write that down over here, and then we will have discussed essentially all the multiplication tables. So the multiplication table for 9, and you already know essentially the meaning of the expressions. For example, 9 times 1 is, for example, when you say 9 times 1, that means 9 groups of 1. 9 times 2, 9 groups of 2, and so on and so forth. So you know that essentially 9 times 1 is equal to 9, 9 times 2 is equal to 18, 9 times 3 is equal to 27, and 9 times 4 is equal to 36. The difference always has to be essentially a 9, meaning that, for example, 27 plus a 9 is 36. 9 times 5 is equal to 40. 45. 9 times 5 is equal to 45. 9 times 6 is equal to 54. 9 times 7 is equal to 63. 9 times 8 is equal to 72. 9 times 9 is equal to 81. And 9 times 10 is equal to 90. Right? Is equal to 90. So that's basically all the multiplication tables of 2, 3, 4, 5, 6, 7, 8, 9, and also 10 we have discussed as well. 2, 3, 4, 5, 6, 7, 8, 9, and 10. Now, if you are in classes, I don't know, if you are in class 2, 3, 4, 5 or something like that, if you are in lower classes, now essentially you have hopefully understood the meaning of essentially the meaning of multiplication and also you have understood hopefully the necessity of memorizing essentially or learning these multiplication tables, because if you don't know how to do that, then you will not be able to do multiplication, the long multiplication algorithm, right? So now that you understand all of this, the only thing that you need to do is that just go through these tables, essentially write them down a couple of times, maybe each 2-3 times, for example, so that they become a part of your memory. And then once we go through essentially the rest of these courses, then there is, well, a whole bunch of calculation that you need to do, and so then automatically everything becomes a good part of good part of your memory, basically. Then it stays there. Okay. And so that's it essentially for the multiplication tables. I'll see you in the next video, and thank you.